What we're going to be doing in this chapter, last chapter of the quad, is we're going to be looking at capital budgeting, which differs somewhat from operating budgeting, which we did in the previous quad. What capital budgeting does is it represents tools a company uses to evaluate different investments opportunities that they have. And the idea is to look at these investments and the potential return on them and evaluate them based on whatever the company's criteria are for what they're going to invest in, the rate of return they require, the point at which they are going to pay the investment back. There are a number of different approaches that we'll talk about in another example, but a couple of the approaches that companies use require an understanding of time value of money, the concept that a dollar today and a dollar in the future are not equivalent. It's highly likely that you have covered this concept in other classes. We cover it briefly in financial accounting. Certainly, if you're an undergrad, we covered it in intermediate accounting. I'm assuming you should have covered it in finance. But I want to present this example, or these examples, of the use of time value of money so that when you get into the material for Chapter 21, you have some foundation. If you already understand calculation of present value and future value, there's absolutely no real reason for you to watch this video. So again, time value of money is the concept that if I offered you $1 today and $1 in 5 years, you would obviously say, give it to me today, because that's not the same thing. If you have it today, you can invest it, do whatever you want with it, but it will not be the same opportunities as if I don't give it to you for a year. But based on your interest rate, based on the length of time, there are numbers where if I offer you A amount today or B amount in 5 years, you would say, I don't really care. Because if you give me A today, I would invest it at my required rate of return, and I would have B in 5 years. Or I'll just wait and let you give me B in 5 years. And this is the whole concept of present value. And what it revolves around, or concept of time value of money, what it revolves around is the fact that your interest, that your return is compounded. And it's compounded maybe annually, maybe semi-annually, maybe quarterly. We're going, in our examples here, we're focusing totally on an annual compounding, just to simplify things. But if you think about it, if you invest $1,000 today in an investment that earns 6% interest, then in this year you will earn $60. Next year, though, that interest will have been compounded into your principal. So next year, the basis of your earnings will be $1,060. So you will actually earn more in the next year. This is the concept of compounding. And if you think about it, the more frequently that interest rolls into the principal or compounds, the faster your investment will grow. So this all revolves around 4 or 5 different factors that if you have all but one, you can always solve for the missing one. And we're going to go through several examples that highlight the different potential scenarios. In this first one, we're going to assume that we have just won $50,000 and we are going to invest it at a 6% interest rate compounded annually. So, some terminology. The $50,000 is the present value. That's the value today. 6% is the interest rate. In this example, what we're asking is how much will we have at the end of 5 years? So that's the number of periods. So those, and what we don't know is how much we'll have. That's the future value. So that is the unknown. So we've got present value, which we know, interest rate we know, number of periods we know. What we don't know and what we want to find out is how much will we have at the end of this 5-year period. There are a couple of different approaches to this. One is you can use present value factor tables. You can find these in your book on pages 931 to 934. There are 4 tables. Table 1 calculates the future value of $1. And so what you'll find in these tables is effectively a matrix. Across the top you have interest rates. Down the side you have number of periods. And so what you're going to do is go across the top, find the interest rate, in this case it's 6%, go down the side, find the number of periods, in this case it's 5, and you'll find the factor that is at the intersection of those 2 points. In this case, that we're in table 1 because we're looking for the future value. The factor is 1.338. So what we're going to do is multiply that by the present value of $50,000, and that gives us $66,900. What that tells us is if we take $50,000 today, we invest it at a 6% interest rate for 5 years, compounding annually. At the end of the 5 years, we will have $66,900. Now, notice this assumes the interest rate is constant. We don't add, we don't take anything out of that investment. Now, that's using the tables. We can also use Excel because Excel has a formula. It's called the future value FV formula. And notice what it does. It pulls in the present value. Well, let me back up. It pulls in first the interest rate, then the number of periods, B6 and B7. Then you'll notice there's a blank because there's the formula, because there is a possibility that you might have a payment, which we'll talk about in a few minutes. And then the present value is B5. And that gives us a future value of $66,911. You should, under the 2 methods, come up with numbers that are close to one another. They may be a little different because this factor from the table is truncated, whereas Excel is calculating down to the dollar. Okay, so let's look at the next one. In this one, we have 12 years from now, the unpaid principal of the mortgage on our house will be $249,600. What we want to be able to do is pay that off at that point. And so the question is, how much do we need to invest today in order to have that dollar amount in 12 years, again at a 6% interest rate, again compounded annually? Okay, so we have the same parameters. Now in this case, we don't know the present value. That's what we're solving for. The interest rate remains 6%. We are looking for not 12 periods because that's when we want to be able to pay this off. And the future value is $249,600. So how much do I need to put in an investment today so that in 12 years I will have this dollar amount? Again, we can use the tables or Excel. If we use the tables, we're going to go to table 2. Remember, table 1 was a factor to find the future value. Now we want to find the present value. So that's going to be table 2. We'll still go across the top, find the 6% interest rate, go down the side, find 12 periods. The factor at the intersection of those points is 0.497. We multiply that by our future value, and what that tells us is we need to invest $124,051 today in order to have enough to pay off our mortgage in 12 years. Again, we can use Excel to do this. We would use a little different formula. The formula we would use here is PV for present value, but the parameters are pretty much the same. It's going to pull the interest rate, the number of periods. Again, we don't have a payment. Payment means you're making a periodic payment, multiple payments. We're not. We're making one today. And then the future value of $249,600. Again, we come up with a number that's very, very close, if not exact. Either way you go about calculating these is fine. It is really your choice. Okay, now we're going to deal with that payment I've been alluding to. Let's say it's a similar scenario to the previous one. 12 years from now, our mortgage is going to have a balance of $249,600, but we don't want to invest today. We just want to put in an amount at the end of every year for those 12 years to make sure we have enough to pay it off. This is where the payment comes in. Present value isn't an issue here. We need $249,600 in the future. 6% interest rate, 12 periods. The issue is how much should our payment be? So what we're going to do here is we are going to go to table number 3, which is the future value of an annuity. An annuity is a periodic payment of equal dollar amount. The table's set up in exactly the same fashion, 6% interest rates across the top, periods down the side. We will find the intersection of 6% and 12, and that will be our factor of 16.87. Now, we're solving for a payment that will arrive at $249,600. So what we're going to do is we're going to take that future value of $249,600 and divide it by the factor. And what that tells us is we need to make a payment each year for 12 years of $14,795. Again, we can do this using Excel. We would do that using what is called the payment function. Works similarly to the fair value, future value and present value. You plug in the rate, the number of periods, and in this case, the future value, which is what we have, and it will give us the payment. Okay. Now, this the next one, the remaining examples I'm going to explain in another video.